In this tutorial, we're going to look at copy constructors in C++. So I've got this class here which I used in the last tutorial, and very simply it's got one instance member here, string name. It's got a method called setName that sets that name, and it's also got a method called speak which just uses cout to output the name of this object. So I'm going to use this here. Let's create a animal object. Let's say animal 1. Yeah, I'll just do that, and let's do animal1.set name Freddy. And I'm going to declare another animal variable here. Let's say animal 2, and I'm going to set that equal to animal 1. And let's do animal1.speak and animal2.speak, and let's see what we've got here. So our second animal just uses the equals operator to assign animal 1 to animal 2. So if I run this, we should see that we've got two animals named Freddy here, and we do. If I change the name of the second animal, animal2.set name to Bob, and we run this, then we find that we can set the name of the second animal independently, because this is a genuinely new animal. Let's add a constructor here to shed a bit more light on what's actually going on here in detail. So if I add a constructor, let's call it animal, and let's implement it inline here just so we can easily see it. I'm going to put in here just a cout animal created. So if we run this, then we get one animal created, and yet as you can see here, we do have two animals. We are able to set the name on the second animal. It didn't affect the first animal, so we genuinely have two separate animal objects here. And yet the constructor is only being called for one of them, and we saw that the constructor normally is called whenever an object is instantiated. So why are we not getting the second constructor being called here? And the answer to that is that we're implicitly invoking a different constructor called the copy constructor when we assign this animal 1 to animal 2. So we do have two objects, but this is using a different constructor. And that constructor is actually setting the fields found in animal 1, setting the fields in animal 2 to whatever's found in animal 1, where it's doing the best job it can. So C++ has implicitly created a special constructor for us called the copy constructor, whose job is to copy the settings from one object to another, but we can explicitly define that ourselves. And if you're going to copy your objects, or you're going to assign them with equals like this, that is a very good thing to do. Let's define a copy constructor explicitly. So a copy constructor looks like this. We've got animal, and then we have a const animal reference like this. I need the ampersand there, const animal reference, and let's call this other, and let's put in the implementation again here. So this is our own copy constructor. Let's do cout here, animal created by copying endler. So now if we run this, we find that we've got one animal created using this constructor and one animal created here using this constructor. Now the purpose of this constructor is to copy the fields of this other animal, which will actually be the one on the right hand side of this equals sign, to the present animal here that we're actually creating. So now, because I've created my own copy constructor, the original one, would no longer work. So if I look at animal 2 now, immediately after creating it, if I call speak on it after I've created it by copying from animal 1, we say that it's got a blank my name is, because we've overridden the default. We've kind of blanked out, if you like, the default copy constructor and created our own, but our new one isn't copying any fields. So we can, nevertheless, and we should, in our own copy constructor, initialize the fields of the present object using this object that's passed in. This object here is going to be this one here on the right hand side of the equals sign. So we can do, for example, in this constructor, something like name, that's the name of the present object, equals other.name. So even though name is private, we can refer to it in the copy constructor because we're still in the same class. And private means you can't access fields outside of the class. But even though this is another object, it's still of the same class, and so we can access private fields here in the copy constructor. Let's check that this works, and we hope to see that my name is will now be filled in with Freddie right here after we've created the second animal by copying the first. So if we run this, it says my name is Freddie, and later we change it to Bob. Now a better way to deal with this is to use the constructor initialization list. So let's do that. Let's put a colon here. We've seen this before. And let's say name, and in round brackets we can supply other.name, and then we can get rid of this here. That's a more efficient way of doing that. And now if we run this, we should see the same thing again. We're successfully copying name. So however many fields you have in your class, when you create the copy constructor, you need to copy them all over to the new object that you'll be creating using this kind of syntax to create a copy of this other object, which is this here. And the syntax of the copy constructor, you must have this const animal reference. So we pass in other is a reference. That means it's not a pointer, so we don't need special syntax to refer to its fields or methods, which is good. It's a reference, so we can refer to it exactly as though we'd really got the object here. But it's a const reference, and that actually means that we can't change this other object, which is what we want. It would be very strange if we did this, and this, which is invoking the copy constructor, somehow changed this other animal on the right hand side of equals. That's not something that we would want to happen, and that's why the copy constructor has to be declared const like this. Otherwise I suppose it wouldn't work at all. The const here actually means that we can't call even any methods on this that are not declared const, because if you think about it, if you've seen the previous tutorials, you'll know that if we could call non-const methods on this other animal here, then potentially those could modify this other animal, and again would end up with this kind of statement being able to modify the object on the right hand side of the equals sign, which is not what we want. So just to prove that point, we can't call here other.speak, or we can't call any method that's not const. Well, this is const. Let's just get rid of const and let's save it, and let's do project.build project, and we get an error. But if we put const back in here, we can call const methods within the copy constructor, even though the object is const, the other object is constant. That does allow us to still call const methods. So now we put that back in, say this method is constant, doesn't modify any of the instance variables. Now we can call speak, because speak is declared const, and the reference is to a const object. So now it works. And if we run this, we've got animal other.speak being called at this point. It's getting a bit confusing to see which is which, but that we can see that we can call that now. Let's just delete that because we don't need it. So I'll get rid of that and save this. Another way to explicitly invoke the copy constructor would be like this. So animal, animal, animal 3, and let's pass in animal 1. So again, that's a valid way of calling the copy constructor. Let's just run this, see that it works. So there we go. So in fact, when you use equals, equals is an operator that is, again, it's implicitly defined for objects. You get like a default implementation of equals that calls the copy constructor. So here, we're in effect, we're calling equals, which calls the copy constructor, whereas here we're using the copy constructor directly. So that, I think, is it for this tutorial. And again, to practice this, define a class and give it, let's say, give it at least 2 fields, and then try seeing what happens when you try playing around just with assigning your object to another object of the same type, like that, and then define the copy constructor and get the copy constructor to work. You can put cout in it to check that it is being invoked when you expect it to be invoked. So get this working using your own copy constructor, and try this as well. And also you can verify that you can't call non-const methods in your copy constructor because of this const here. It's worth actually checking that you do get an error if you try to call a non-const method, or for that matter modify a field of other here. We can't do this either, because again that violates the fact that this reference is to a const object. So if I put that in there, that's also not going to work. So have a go yourself if you've got that energy, inclination and motivation. Try defining your own copy constructor. And again, this is something that's used quite a lot in C++. And as always, you won't feel comfortable with it until you've used it quite a bit in your own programs. But if you even just go through this here, type it out and get it working, then that's a really big, important step forward. So until next time, happy coding.